Good morning or good afternoon, everyone. Uh, Quickly, as some of you maybe doesn't see me last lecture. So again, my name is Ahmed. I'm a mechanical engineer, graduated back in 1983. And I am in oil field industry since that time up till today. So I'm 63 years old now. The course you are attending, the name is well intervention, but it is not a deep course in well intervention, but it's just an introductory to the well intervention. Of course, the bad side of the story that I don't know what is the qualification of each one of you hearing me now or listening to me or seeing me. So I assume that you know a little bit about oil field industry. So you might face during the course that some terminology or some topics that I'm talking about you are not familiar with. I would like to hear the feedback that you will send to Dr. Ahmed Al-Garhi. So I know that if I'm going deep or I should make it much simpler next courses. What we are going to talk about in the oil field industry as a well intervention, we are talking about barriers. We are talking about a little bit about information damage, a little bit about completion, a little bit about two services that we do, which is wireline and coiled tubing. A little bit about calculation. So everything is just a little bit. We will not go deep in any of these. Last lecture, we start talk about the barrier. Just to recap, what kind of well service disaster could happen and caused by pressure. It's a blowout. A blowout is, as a definition, it is uncontrolled pressure. And the word pressure is what makes disaster in the oil field. So if there is no pressure in the oil field, we are in heaven. But actually we are not. So pressure is something really we have to respect. You guys has to know that 3 psi kills a man, not 300 or 30 or 3,000. I'm talking about just 3 psi can kill you. What causes a blowout in any oil field? It is barrier failure. The barrier you are using failed to do his job. What's the definition of a barrier? We say it's any device, fluid or substance that prevents the flow of well-bore fluids. In this statement, there is one word I don't like, which is the word fluid. I should change it. I should say any device, liquid or substance. Because fluids, when you talk about fluid, then you talk about liquid and gas. Gas cannot be used as a barrier because it doesn't create hydrostatic head. So normally it is a liquid that prevents the flow of hydrocarbons. The examples we have in oil field as a barrier that prevents the flow of hydrocarbon is the Christmas tree, of course. The Christmas tree, which is on top of the wellhead, it prevents when you close the valves, whatever swap valve, master valve, it prevents the flow of hydrocarbon. The wireline plug, there is a plug. We run it with a service called slick line or wireline that we go deep into the well and sit it in the completion in something we call landing nipple. So this plug will prevent the flow of hydrocarbon as long as it is there. BOB. BOB stands for blowout preventer. The blowout preventer, it does prevent the flow of hydrocarbon. Fluid. If you create a fluid on top of the formation downhole, this fluid you create, it creates hydrostatic head greater than the formation pressure, then it's a barrier. DHSV, which is downhole safety valve. It's a valve. We put it downhole near the surface, around maybe 200, 300 feet below the surface. We put it in a landing nipple as well. When it is closed, it prevents the flow of hydrocarbons. And this device, which is downhole safety valve, we can activate, open and close by a control line from the landing nipple below all the way to the surface, where in the surface I have a control panel or a high pressure pump that it can open and close this valve. All these devices you see written in green, I can use it as a barrier that prevents the flow of hydrocarbons. These barriers we are using, we classify it into three categories. We have three classifications: primary barrier, secondary barrier, tertiary barrier. Normally, when we run in the hole under pressure with a service line, slick line or E-line or electric line, or coil tubing, normally when we run in the hole, we have a device that seal around this slick line or this pipe while in the hole or out of the hole. This is normally the primary barrier, which normally it's a packing, a kind of packing. And if this packing, which is our primary barrier, failed, what does it mean by failed? This is the pipe you are running, and this is the seal you have. During running the hole, there is a friction between this pipe, this steel element, and the rubber. This friction caused the rubber to be weird. So there will be a gap between the rubber, and if this happens, what we do normally, we increase the pressure on this rubber element that seals around the pipe or around the wire to prevent the flow of the hydrocarbon. So if this rubber items leak, it is not fail, because you still can put some pressure to make it seal. But when can I call or can I say that this rubber element failed? When you apply the maximum pressure you can apply to the seal and it's still leaking. Now it is failed. This is the difference between leaking and failing. If it failed, then the primary barrier is no longer a barrier. Then we have to go to the secondary barrier. But before you go to the secondary barrier, first thing you have to do is you have to stop the operation. Because the primary barrier, it is the only barrier that works while in a hole, in the hole or out of the hole. All other barrier you can imagine or think of to apply, first thing you do is to stop movement. All other barriers, they don't work while in and out. They work in a static condition. So if the primary barrier failed, we go to the secondary barrier, but first we have to stop the operation. Then we go to the secondary barrier. The secondary barrier normally in our operations, in our well intervention services, it is the BOP, blowout preventer, which is a device having so many actuators. One of them, we apply pressure, so it closes this piston and cylinder. It closes to seal as a rubber element that seal around the pipe. This is our secondary barrier. If we apply the secondary barrier and it failed, then we have to go to the tertiary barrier. The tertiary barrier could be another BOP, we call it shear seal BOP, that shear the pipe or the wire and seal at the same time. And this device has to be actuated from your control cabin, the normal control cabin, and also from a separate control panel, remote one. You can put it away from the location up to 200 feet. The way we do it this way, what if situation happen, you need to prevent a blowout, but you cannot access your control cabin, or the field or the area you are working in is full of exposed. You cannot access it for some reason. That's why you can seal your rig, your your well from a remote area, safe area. The shear seal also not necessary to be in every rig up you have. So it might your tertiary barrier might be the Christmas tree itself, where you can close the valve to seal. Closing the valve, yes, you can use the master valve. Normally, it cuts the slick line, because the slick line is a stainless steel wire, one way, the diameter of it. So master valve can cut it. Some master valve are designed to cut this slick line. Not all of them. It has to be designed for. So these are the sequence. Primary barrier, if it failed, we go to the secondary barrier. If the secondary barrier failed, we go to the tertiary barrier. It came through my mind now a question that I need you to ask. Let us assume that you need to do a perforation job, that you need to go with E-line. You run a hole 3,000, or make it 13,000 feet deep. Then with what we call perforating guns, you need to perforate. You shot guns that penetrate the casing and penetrate the formation itself. Then you have these nodes, which allows the flow of the hydrocarbons into the well. So let's assume that we prepare for this job. We rig up our pressure control equipment on top of the Christmas tree, and we tested to 5,000 psi. Everything went perfect. So now we have Christmas tree. We have our equipment on top of it, including our pressure control equipment. We test the whole package to 5,000 psi. Everything went okay. We start running the hole with the E-line, electric line, that has the shooting guns, perforating guns. And then we went through the well, the length of the well. The well is full of mud. The mud density is 9 ppg, 9 pounds per gallon. We run all the way. When we reach 13,000 feet, the supervisor or the operator on the top, he pushed the button. So the explosive charge. Now the guns hit the casing, make these holes, and hits the perforation, make the nodes. And now you start producing, not producing, but pressure starts coming out from the formation. At that time, you have a gauge on the surface. This gauge reads 5,020. My question now, can you continue the job? Remember, before the job, you test your Christmas tree and pressure control equipment to 5,000 psi. Now, after you perforate, the hole is full of mud. The surface pressure reads 5,020. Can you continue the job or not? I'll leave you a few seconds. Of course, I will not hear your answer, but I can imagine it. Finished thinking already? Let me tell you. Some of you guys believe, yes, you can continue the job. Come on, Ahmed. It's just 20 psi. There is no harm. Some of you will say no. You test your equipment before the job to 5,000 psi. So you are allowed to use this equipment up to 5,000 psi. If the pressure exceeds 5,000 psi by 1 psi, you cannot resume operation. You cannot continue, sorry. You cannot continue. Some of you will say, but come on, Ahmed, when we test this BOB, as per the API standards, when we certify this BOB, we test it to 1.5, its test pressure, its working pressure. So this BOB, which is rated for 5,000 psi, when we test it for the purpose of certification, we test it to 7,500. So me and you know, Ahmed, that this BOB will withstand up to 7,500. So what's the harm of using it at 5,020? I said, no. If you remember, I believe last time I said, this difference between 5,000 psi and 7,000 psi, 7,500 is not for you to use into the operation. This is to save your life, in case of emergency. Do not ever use it in operation. This BOB is rated for 5,000 psi. Never use it above 5,000 psi. So now, if we cannot continue the operation, what should we do? Some of you will say, okay, in this case, Ahmed, we have to pull out of the hole, rig down, change this BOB to, or pressure control equipment to 10K, so we are safe. I said, you cannot do that. Because to pull out of the hole, you need 2 hours to reach the surface to rig down. You are exposing the area to a hazard situation. You are exposing your pressure control equipment to excess pressure that you didn't use it when you tested. You cannot. I'm afraid that the only solution you have now is to cut your E-line, drop everything, and close with your Christmas tree. Then people start crying. Do you know, Ahmed, the solution you just gave me, how much money I will take from my pocket to overcome what you did? Do you know this job that is wasted now? It costed me 6 zeros. I said, when I talk about people's life, please, 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 do not talk about money. When we talk about people's life, people injuries, do not mention money, please, please. So the only solution in this particular case, I told you, I'm afraid is you have to cut your E-line and close the Christmas tree, secure the well. Normally, our primary barrier, we call it stuffing box or the stripper rubber, which is a rubber element that seal around the pipe or around the wire. The secondary barrier is our BOB. Our tertiary barrier, normally it's either a shear seal BOB or a Christmas tree. But you guys has to know that the barriers play with each other as a team, meaning that if the primary barrier failed, then you stop the operation, you close your BOB, secure the well till you repair your primary barrier. When you close your secondary barrier, which is the BOB, if it closes and seal around, then if you ask me, what is this, Ahmed, I will say this is our primary barrier. So the BOB, which is originally a secondary barrier, it became a primary barrier now. And it keeps doing as a primary barrier till you fix your primary barrier, which is the stuffing box or the stripper. It's back to work. Now you open your BOB, it goes back as a secondary barrier. The same thing happened to the tertiary barrier or tertiary barrier. So these barriers plays together as a team. They cover each other. I have a little question. Let us see this. What can happen when you unset a retrievable bridge plug and don't have enough weight above it? What is the retrievable bridge plug? It's a plug that has a rubber element. This rubber element, it inflates by temperature. We run this retrievable bridge plug. We run it through the production tubing by E-line. It goes out of the production tubing. Then it goes to the casing. Then we set this retrievable bridge plug to seal around casing walls, not around the tubing walls, around the casing wall, where this rubber element inflates, so it seals to a larger diameter. We set this retrievable bridge plug, and now we do our job, we finish our job. We need to retrieve this bridge plug. Normally, you retrieve it by overpulling. My question here, you see it, what happened if you retrieve it and you don't have enough weight above it? Normally, before you retrieve it, you have to equalize the pressure. So the pressure above it will be equal to the pressure below it. If you didn't do that, you try to retrieve it while pressure below it is greater, what will happen is this. What you see here is a blowout. A blowout will happen. And what you see on ground here, it's a 3.5-inch pipe. This pipe was inside the well. It's a completion tubing. Who bring it to the surface? Who brought it to the surface? It's pressure. It's pressure. What you see here, this is one of the impact on the blowout. Yani, if you ask me, what's the impact, Ahmed, on the blowouts? If a blowout happens, I said, first thing you will see that it's life loss. People will die. Number two is what you see here, environmental loss. Number three, financial loss. You're going to lose your environment. You lose your reservoir. Number four is your reputation. You lose your reputation. Number five, we say extra governmental regulation. What do we mean by extra governmental regulation? That when a problem happens, we start putting rules, try to prevent this from happening again. Like exactly these days, if I have a bottle of water, I cannot take it with me to the airplane because something happens. So they start, like now, yani, you guys are traveling most of the time. Yani. In the past days, I used to go maybe 1.5 hours before a plane, no problem. I finish all the regulations and customs in no time. But nowadays, you have maybe 10 checkpoints. You pass by one, you face another one, you take your clothes off, then you take your clothes off, then you take your clothes off, then you go walk naked to save wearing and taking off your clothes. Extra government regulation. This is the production tubing. You can see it. You can see the joints here. And this is our retrievable bridge plug. This is the bridge plug that was deep in the well. And what you see here, this is the rubber element. These are the rubber element that inflates to seal around the casing. Where did they find it? If you measure this distance from here all the way to the rig site, this is 400 meters. 400 meters, almost half kilometer. This plug was not there. It was deep, many thousands feet in the well. Pressure did that because you didn't equalize the pressure. Actually, what you see in front of you now, I mean, this bridge plug, it's a barrier, but you misuse it. If you misuse a barrier, it will create blowouts. So what's the API recommendation of barrier? The API said that for any particular job you do, whatever it is, drilling, workover, wireline, coiled tubing, snubbing service, whatever it is, a minimum of 2 tested and available barrier. You should have at least 2 tested and available. Available mean you can use it. But you might have a BOB and the BOB is tested and you have the certificate of the BOB, but you are in the field now and the BOB is at your home. So it is not available. So it's not a barrier. If I have a BOB, this BOB is rated for 15,000 PSI. You put it on the Christmas tree and then you ask me, Ahmed, what is on top of the Christmas tree? I will tell you it's a piece of iron. Piece of iron. Come on, Ahmed, it's a BOB. I said, no. It will be a barrier after the test. If I test it and passes the test, it is a barrier. But before that, it is a piece of iron. We talk about the barrier classification and we say that we classify the barrier into 3 categories: primary barrier, secondary barrier, tertiary barrier. When we talk about the barrier types, we'll say that we have 2 types of barrier. 2 types of barrier. Either mechanical or hydrostatic barrier. In mechanical barrier, we have 2 types of it. Either closed type or closable type. What's the difference between them? In closed type, it is closed throughout the operation, like the wireline plug you are using. If you set a wireline plug deep in the well or anywhere in the well, and this plug, it's closed type because as long as it is there, there is no production. It's like the stuffing box with the stripper, this rubber element that you seal around the pipe or the wire while running in the hole. It is closed type. But the closable type, it is closed when required. It's like the blowout preventer. The blowout preventer, normally when you are running in the hole, pulling out of the hole, it is in open position. When you close, when you need, if the primary failed, then you close it. So it is something that you can close and open. This is the difference between the closed type and the closable. The other type of barrier is the hydrostatic barrier, which is mainly liquid. A liquid that creates hydrostatic head, HP means hydrostatic head pressure, greater than information pressure. If I put full stop now, this statement is wrong. Because you can come, I have the formation pressure 3000 psi, and then you create a fluid. You put a fluid on top that creates 6000 psi hydrostatic pressure. Is it correct? Of course not. You are breaking my formation. So it has to be within a little margin, greater than, but with a little margin, 200 to 300 psi. I cannot put a full stop yet. Monitor it all the time. If you are using a fluid as a barrier and it creates hydrostatic pressure greater than information pressure within a reasonable amount, and you cannot monitor it, it is not a barrier. That's why during drilling, the mud engineer normally takes samples from this drilling fluid to be sure that its density, it is within the design density. Otherwise, it is not a barrier. Some new terminology now. Temporary barrier, permanent barrier, active barrier. What's the difference between these barriers? A temporary barrier, this is a barrier. We use it temporary on location. But then we can take it, use it another place, another country, another continent. It's like the BOB. The BOB, you move it from a well to another, you take it to the yard, you send it to another country. It's temporary. But casing, we consider it permanent barrier, because when you run the casing, then you cement it. Plus, you cannot take it out. It became permanent barrier. But by the way, the moment you perforate it, it is not a barrier anymore. It became something else. We call it barrier envelope. But it is the permanent barrier as long as it is not perforated. This is what we mean by permanent barrier. And there is a difference in how we pressure this and how we pressure that. Both of them, they go with the same concept that if a temporary barrier or permanent barrier, you suspect it leaks, please test it. So you can test it every 1 hour if you like. But the main difference is the temporary barrier, you test it before you use. While a permanent barrier, you test it after installation. A BOB is a temporary barrier. That's why you test it before we use. But the casing, since it is a permanent barrier, you test it after installation. You have to run the casing first, then cement it, then you test it. The last thing is the active barrier. What is the active barrier? It is the barrier you are using now. And if I ask you a question, you rig up on a Christmas tree to run slick line operation. When you have the Christmas tree, you put a blowout preventer, a BOB on top of the Christmas tree, then you put 2-section lubricator, risers, then you put your stuffing box. Then how many barriers you have now? You have a stuffing box, you have the BOB, and you have the Christmas tree. You start running in the hole. And while running in the hole, the stuffing box leaks. My question is, how many active barrier you have now? I will repeat the question. I have a Christmas tree. I rig up my slick line where I have on top of the Christmas tree, I have a BOB, then 2-section lubricator. Then I put the stuffing box, which is my primary barrier. I start running in the hole. While running in the hole, my primary barrier is closed to seal around the wire while running in the hole. And I have another barrier, which is the BOB. I have another barrier, which is the Christmas tree. During the operation, the primary barrier, which is the stuffing box, leaks. The question is, how many active barrier you have now? I will give you a few seconds to think. How many? 0. Come on, Ahmed. How come you say 0? We have the BOB, we have the Christmas tree. Yes, you have it, but they are not active. They are sitting by in a Starbucks cafe, playing chess, waiting you to activate them. They are standby. They are not playing. They are not working. They are open. They are idle. The only active barrier you have was the stuffing box. It was closed, sealing around the wire. The moment it leaks, you have no active barrier. You have 0 active. When you close the BOB, then you have 1 active barrier now, which is the BOB. But before you do that, you have 0. 0 active. This is what do we mean by active barrier. How it is the barrier. Now, we are using our line plug as a barrier. We put this plug deep in the well, at 6,000 feet, for example. We need to test it. Or we have a BOB at the surface. One of the ram is a blind ram that seals itself to prevent airflow of hydrocarbon in case of emergency. Or we have the stuffing box or the stripper, this rubber element that seal around the pipe. How we test it, from which direction we test it. Here it comes the answer. Direction of flow. Direction of flow. Please don't tell me from below or from top or from the side. It is from a directional flow, regardless the directional flow comes from where. It is common that normally when we work in oil field, we work in the wells, pressure coming from below. So it doesn't make any sense actually that you have a blind ram on a BOD, you need to test it, then you close it, and now you test it from above. This is a joke. Because actually, why you have it? You have it to protect you. How? If you have a blowout, you can close to protect the pressure from this direction. So you have to test it from this direction. And actually, it is not designed to withstand pressure from top. Some of you will not believe me. So what they will do is, after we finish the lecture, you will go to the yard, having your BOB, close your blind ram, and then put 3,000 from top, and it holds the pressure. Then the following session, which we'll have it, inshallah, next Sunday. So you will show me this graph you have, the record, the chart recorder you have. Come on, Ahmed. I test the BOB from top, and it holds the pressure for 30 minutes from above. I said, yes, I believe you. I believe you did that. But what I'm teaching you here, that if the traffic light is red, please do not cross the street. But it is true that you said, Ahmed, last week, I crossed the street 3 times while the traffic was red. Nothing happens. I said, yes, I believe in you. But believe me, one time, you will cross the street when the traffic light is red. A car will hit you. You will go up, but you will never come down. You will wait up there till we come visiting you after a long time, inshallah. So please test it from a direction flow. Everything we design for a certain purpose. We designed the valve to be used fully open or fully closed. So one of you, while in the field, there is a frac tank. Frac tank is a tank that weighs, actually, it holds 500 barrels. So we have this big tank, horizontal, which holds 500 barrels of water. It is full of water. And let's assume that you are a Muslim. You need to wash your hands and face to go to pray. At the bottom of the tank, the side bottom of the tank, there is a butterfly valve, 3-inch butterfly valve. So you open it partially, then you have this little stream of water coming out, so you can wash your hand and face and go to pray. Once you finish, you close the valve. What you just did is a fatal mistake. The butterfly valve is designed to hold or to work either fully open or fully closed. By opening it partially, allowing this stream of water to come across, it erodes the sealing part. You will not notice this from the first time. You keep doing this, it is an accumulated. Each time you do that, this butterfly valve will keep it in his memory. Then after 4 or 5 times, you do the same, you close, it will not hold the pressure. You destroy it already. The sealing part, it is totally eroded. Please, we have design the ladder so I can put it on the wall, so I can go all the way to the top of the ceiling to change the bulb. But you can tell me that I will put the ladder horizontally between two discs so I can cross like that. Yes, you can do that. But one time while crossing at the middle, the ladder will break. Because when we designed the ladder, we didn't put into our consideration this force that comes from this direction. The stress analysis we did doesn't include this. So please do use the equipment for the purpose it is designed for. Talk about the valves, either fully open or fully closed. Pressure control equipment, use it from a direction of flow to hold the pressure from a direction of flow, not from any other. Okay, we said that when we test a barrier, we test it from a direction of flow. Let us have a plug now, a wireline plug, that we set it deep in the well in the tailpipe. What is the tailpipe? The tailpipe, it is a part in the completion. The completion, it is a series of pipes connecting together with a lot of accessories. And they have what we call a parker. The parker, anything above the parker, we call it top completion. Anything below the parker, we call it bottom completion or tailpipe, which is actually two pieces of pipes with a lot of accessories. So now we put this plug below the parker in the tailpipe, and we need to test this plug. Remember, when we test from a direction of flow. Let us test it from a direction of flow now. How? How we test it? The only way we test it is where we use a well pressure to test it. When we put a plug, we put it against the well pressure. Once you put the plug, bleed off the pressure above it and close at the surface. And have a chair now. Sit on the chair, look at the gauge at the surface. If the gauge moves up, the pressure increase, that means this plug is not holding the pressure. This is what we call inflow test. Or in some areas, they call it negative test, leak off test. This is the only way to test it. You cannot apply pressure from below it. You have no access. So the only way is to use the well pressure to test it. This is what's the inflow test. This is an example of the two barriers we talk about, mechanical barrier and hydrostatic barrier. Mechanical barrier, we said it is either we have closed type, closable type. Closed type is like stripper, the grease injection head, which we use it as stuffing box, but it is for E-line service. The wireline plug is a closed type. But the closable is like the BOB or the Christmas tree. The hydrostatic barrier, it is fluids normally, liquids like drilling fluid, completion fluid, fresh water, salt water. All these are considered as fluid barriers. The two little question I have for you here is diesel. Then I put question marks. Can I use a diesel as a barrier? Yes or no? I'll give you a few seconds. Can I use a diesel as a barrier? No. No, I cannot. Why? I have two concerns. Number one, it is flammable. So safety-wise, I cannot. Number two, normally it is lightweight. It does not create enough hydrostatic head to kill the well or to use it as a barrier. This is in common, yani. If we go in deep, we might say something else. meaning that in this course, I'm here to say that poison is a killer. This is an absolute fact, right? If you have a bottle full of poison and you drink it, normally you will die. Unless you are a Heracles or Superman, and you can drink poison normally every day. But it is also true that in some medicines, in the ingredients of these medicines, you will see poison. This is the special case. So diesel, we use it as a barrier, yes, in special cases, normally in sensitive formation or low pressure formation. But generally, I cannot use a diesel because of these two reasons, flammability and lightweight. Nitrogen. Can I use a nitrogen? Time is passing like rocket. Nitrogen. Can I use a nitrogen as a barrier? Of course not. It is very light. It will not create any hydrostatic head. Yani, if I am sitting downhole in one of these landing nipples, have a chair and sit at 10,000 feet, and you fill the hole with nitrogen, I can lift this 10,000 feet of nitrogen with my hand. It has no weight. Although it is an inert gas, yes, it's an inert, but it is light, so I cannot use a net. I cannot use a net. I will skip this, which is the barrier envelope. I'll skip it. Remember, this course, I teach it in 5 days, 8 hours each day. So I have to skip some items here. These are some definition. What's overbalance? It is greater pressure than information pressure. The opposite of that is the underbalance, which is less pressure than information pressure. In inflow test, we agreed that the inflow test that where you bleed off the pressure above these valves, these plugs, and monitor it build up to see if there is build up or not. Let me ask you this question about what is the formation fracture pressure? If you need to define what formation fracture pressure is, can you tell me? Look at this word. This is statement. It is the maximum pressure applied to the formation before it breaks down. This is the definition of the formation fracture pressure. It is the maximum pressure you can apply to the formation before it breaks down. Or I can be smart enough. I will remove the word before and instead I put when. So the statement is maximum pressure applied to the formation when it breaks down. Yes, again, it is correct. The difference between before and when is 1/100 of psi. So before it breaks down or when it breaks down, both are correct. Double barrier theory, this is something maybe I will go through it quickly. The double barrier theory says that in the old days, when we used to pressure test, and finish pressure test, run in hole, finish our job, start pulling out of the hole, when we reach the surface, we go to the Christmas tree at the top valve on the Christmas tree where we call it swab valve, and then close the swab valve, preventing the hydrocarbons. Now, this swab valve is closed. I bleed off the pressure above it till it is zero. Now I can disconnect my equipment and leave. But before disconnecting my equipment and leave, what we used to do is close this swab valve, bleed off the pressure above it to zero, then close. Sit on the chair for 10 minutes watching the gauge. What I'm doing now, I'm doing inflow test to the swab valve to be sure that it is holding the pressure below it. Yes, I did the test before the job, yes, but I have to do the test now again. But these days, once you close the swab valve, bleed off the pressure, close, inflow test it, then open, disconnect. Before I do that, I cannot do that against one valve close. I have to close another valve in the Christmas tree, which is the master valve, the upper master valve. So I am testing, I am opening now against two valves, not one. But these two valves are inside one barrier, which is the Christmas tree. The Christmas tree is three valves. There is normally a three valve in the Christmas tree. Swab valve, upper master valve, lower master valve. But I cannot, each one of them, if you close it, you will secure the well. But we cannot say that the Christmas tree is three barriers. No, it is one barrier because it is one body. One body means one barrier. Let us assume that you have two BOBs on your rig. How many barriers? One barrier. They are two BOBs, yes, but they are doing the same function. So if I put 6 stripper rubber or 6 stuffing boxes, it is one barrier because they are doing the same function. So same function, same barrier, same body, same barrier. So now to rig down, I close the swab valve and the upper master valve. I close against one barrier, but I double the barrier. Double the barrier means it is the same barrier, but I doubled it. It's like exactly, I don't like junk food, but when I go to McDonald's, I like fish. So I go to McDonald's and I ask for fish sandwich. Normally the fish sandwich is one layer of fish, then they put one slice of cheese. This is the sandwich. But when I paid at the cashier, I said, I need fish sandwich, but double layer, please. Double layer means 2 layers of fish, not one. I pay extra money, yes. When I have the sandwich in my hand, it is one sandwich as a classification, but I doubled it. I doubled it. I have 2 fish layers, 2 pieces of fish, not one. This is what we mean by double barrier. It is the same barrier, but you double it. I will go quickly, information damage to end up our session today. So please give me 7-8 minutes more. What damage information? What is the formation? The formation is the layer downhole contains the hydrocarbons. How can I damage? Too easy to damage. There are so many ways to damage information. But if we need to talk about the 2 most common or most important factors that damage information, it is pressure and fluid. When I say pressure, I mean exceeding information fracture pressure. If the formation fracture pressure is 3,000 and you apply 6,000 to this formation, you break it. You damage it. So people ask me, break a formation? Is it a glass to break? No, it's not glass. But breaking a formation, if some of you doesn't know what formation, the content of the formation, if we go deep in the well, going to the formation and have a microscope to see what it is sand. It is pieces of sand, particles of sands. But these sands, there is a distance between each piece or each particle of sand. You will not see it by naked eyes, you see it by microscopes. And these distances, very tiny little distances, that's where the hydrocarbons flow through. Now, if you exceed the formation pressure, if it is 3,000 and then you apply 5,000, you break it, means that this distance between these particles will start to be either this way or that way apart. But the time you stop the pressure, the formation will collapse. No more distances between information, between the particles. That's why you damage it. So exceeding information fracture pressure will damage information definitely. The other thing is fluid. How will fluid damage information? We have three things. Number one, it is pressure. If you put fluid that creates hydrostatic head, much greater than information pressure, you damage it. The other thing is the compatibility. Compatibility. If I have a jug of steel, I cannot fill it with acid because acid and the steel are not compatible together. But if I have a jug of plastic jug, plastic cup, I can fill it with acid, yes, because acid and plastic are compatible. So any fluid we are pumping into the well, this fluid has to be compatible to the formation. Otherwise, it will damage it. The last thing is cleanliness. The fluid we are pumping through formation, it has to be clean. You have to be sure that there is no scales, debris in this fluid. Otherwise, it will plug these roads, this tiny distance between the particles of sand and plug your formation. These are the two main factors, pressure and fluid. If we talk about pressure also, we can talk about the surge pressure and the swap pressure. What is the swap pressure? The swap pressure is while you are pulling out of the hole too fast and you don't have enough clearance between the OD of your tools and the ID of your tubing. By doing this, pulling out of the hole while there is no gaps, you are sucking. Elzeftawy is the opposite. You are running in the hole too fast and you don't have enough clearance between the tubing and the OD of your tools, so you are injecting. Swapping and injecting, if it is not planned, it will damage your formation. And I was using the word fast. Actually, the opposite of fast is slow. S-L-O-W. The word slow in our life, it is a disadvantage. You walk slow, you think slow, your reaction is slow. So slow is a disadvantage. This is in our life. But in the oil field, slow is the correct word you use. When you run in the hole, slowly. When you pull out of the hole, slowly. When you pressure test, slowly and in stages. And when you pressure test to 5,000 psi, you should not go from 0 to 5,000 immediately. You go from 0 to 1,000, then from 1,000 to 1,500, then to 2,000, slowly and in stages. When you bleed down, pressure, slowly and in stages. You cannot bleed down from 3,000 psi to 0 in no time. Slowly and in stages. Of course, each piece of information I give you, we can talk about 1 hour. But of course, I'm limited with the time. Slow is the correct word in the oil field industry. The only time, as far as I know, the only time I read in an API standard quickly as a correct word, it is when we need to test, when we need to close the flowing valve. The Christmas tree, it is from bottom, it is the lower master valve, then we have an upper master valve. Then you go this side, you have flowing valve that allows the flow of the hydrocarbon to the production line facility. When you close this valve, close it as quickly as possible, not slow. Why? To minimize an erosion. Because this valve, you close it this direction, against flow coming in this direction. So this flow, if you close this slowly, this flow, it will erode the sealing part or the sealing surface of the gate valve. This is the only time, as far as I know, that I read in an API that the word quickly is the correct when we close the flowing valve. Rather than that, slowly, please. 1 hour passed already. So we are done for today. If you have any questions, Dr. Ahmed, I'm ready for it.
Mohandas Ahmed, thank you very much for the amazing webinar as usual. Let me get 3 questions. Someone asking about the DHSV also used during drilling beside production? The safety valve, downhole safety valve?
A downhole safety valve does not exist in drilling. It does exist only on production wells, where we have an extra safety device that we put below the surface to protect this device from ourselves. And we can open and close using a control device, a control panel. This device, we use it in production wells only.
A second question, which well intervention method damages more the formation and how to reduce that?
It's exactly like you ask me, which car create more accidents? Is it Mercedes or BMW? Can you answer this question?
It depends on the driver.
The mistake is not in the car. The mistake is in yourself. How you do the job, how you plan to do the job, how you know that the capability of your equipment, how you do it safely as per the book. So there is nothing can damage anything unless you are misusing it.
Okay, last question for today. When installing a screen, how do you maintain 2 barriers?
When you're installing a screen?
Yes, how to maintain 2 barriers?
I will assume that he is saying that when he talk about screen, I will assume that he is talking about the sand screen that we used instead of the gravel backing. We put the sand screen with the completion downhole. This sand screen, it prevents the sand that coming out of the perforation of the formation that comes inside the production tubing to erode this production tubing. I will assume that. Why? Which means that this sand screen, when you run it with the completion. So what you will have always, the well is dead by overbalanced fluid. You have overbalanced fluid. This is number 1. Then you have on the surface what we call you have safety devices connected to a drilling pump that you can kill the well immediately through these devices immediately. These are the 2 barriers we are using.
Engineer Ahmed, thank you very much again for all the attendees. Thank you for attending. And for sure, we will see you again on Sunday at 3 p.m. And now we can say enjoy your rest of the day.
Okay, sir. I'll see you
Sunday,
inshallah.